All right. This question is from the chapter called Developing a Formula, Setting Up Linear Equations. So we need to solve this by setting up some linear equations. Let's try and form these equations using the information given. All right, a rectangular garden is twice as long as it is wide. So they've done a little thing, a little diagram for this problem. There's a garden here, and the garden has a path 1 meter wide around it. Okay, this distance is 1 meter. This distance is 1 meter. May as well do it the full way around. The length of the perimeter of the outside of the path is 60 meters. Let's write down some of this information. What is the width of the garden? All right. Rectangular garden is twice as long as it is wide. So I'm just going to say some information. I'm going to say the small rectangle. What can we write about it? Well, this green rectangle, we have that the length is 2 times the width. And that can be a bit tricky to understand, but if you get your variables mixed up, you might be able to realize pretty quickly. So for instance, if I was to accidentally write width equals 2L, you ask yourself, does that make sense? Well, my width can't be 2 times the length. It wouldn't be the shorter side then, would it? It would be the length. But hopefully that makes sense. So I can write something like that. The length is 2 times the width. So I could, if I've got my width here, oops, my width is this side, and my length is 2 times the width, I can write that full thing in terms of W. Length is equal to 2 times the width. That's a key part to this problem, is realizing that. You want it in terms of one variable. Okay. The garden has a path 1 meter wide around it. The length of the perimeter of the outside of the path, so the, so it's the outside of the path. So we're dealing with the big rectangle now. The length of the perimeter, or the perimeter of the outside of the path, is 60 meters. And we know a formula for perimeter, right? Perimeter of a rectangle is 2 length plus 2 width. And this will have to be of the big rectangle. These will have to be of the big rectangle, not the same as this small rectangle's length and width. Now let's try it out. What is the width of the garden? So we actually want to solve for that W somehow. That little W. All right, it's lots of fun. Let's get a different color. If that helps at all. Now the key is to draw those little 1 meters all the way around the outside. And we are going to try and do the same thing for this big rectangle. I'm going to try and write the length in terms of the width. But I'll let you know how we go. So we're going to first look at this vertical distance. Should be a straight line, but it's not. We're going to look at the vertical distance. Now that's made up of this plus this plus this. So 1 plus W plus 1, which is 2 plus W. We want to write everything in terms of the width of this garden, because then we can eventually solve. Now I'll get a different color. Let's get some pink going. Now we're going to look at this. Oh, I tell ya. We're going to look at the length of the big rectangle by looking at these horizontal distances. Takes a while to get your head around. So it's going to be 1 plus, well, we define that as 2W. I'm going to write it down. 1 plus 2W plus 1 again. And that gives us 2 plus 2w for our length of the big rectangle. I'm going to say length of the big. Oh. And let's call this width of the big. Important, okay? So, then what we have, we've got this formula here, and there's two unknowns. We can't solve it, but we do have some information. We could rewrite this length in terms of the width, right? We could rewrite this width in terms of the width here of that smaller rectangle. Oh man, I hope this is making sense. So 60 equals 2L plus 2W. Bit of substitution, right? We're dealing with two different rectangles. Big rectangle. I'm going to substitute 2 times the length of the big rectangle. Let's do it in pink. Length of the big is 2 plus 2W. Now, plus 2 times the width of the big. So 2 times 2 plus W. And now we have this all in terms of W, the width of this smaller garden, the smaller rectangle. So we've got only one unknown and we can solve it. So that's nice. How can we solve it? Well, we can't simplify inside the brackets, so let's expand. Expand using the crab claw. 2 times 2 is 4. 2 times 2W. So we add that on. 2 times 2W is 4W. Plus 2 times 2 is 4. Plus positive 2 times W is 2W. Whoop. Next step. Let's get rid of those guys. Collect like terms, right? This side stays as 60. Collecting like terms. This is a like term. This is a like term. Now we've got some normal numbers. 4 plus 4, 8. 4W plus 2W, 6W. We're getting closer to solving for the width of the small garden. I want this on its own. I'm going to take that 8 over to the other side because it's furthest away from this. So I'm going to say 60 take 8 equals 6, leaves us with 6W. 60 take 8, 52. 6W. And we've only got the W being multiplied by 6. So what's the opposite of multiplying by 6? Dividing by 6 on both sides. So 52 divide 6 gives us 8.67. And what were the units? Well, they were in meters. We input them as meters, so they must come out as meters. And they wanted the answer in centimeters. So 867 centimeters. So move that decimal place 2 to the right. And that's how you do it. You're just trying to translate this English into maths. And that's a bit of a weird one here. Twice as long as it is wide. So you can rewrite that length in terms of W. Because we want to solve for W in the end, right? The width of that garden. So we realized that there was a small rectangle, and then we were given some information about there being a path around it, 1 meter wide. We did that on all sides, put that meter in. And then we were given the length of the perimeter of the outside of the path was 60 meters. So we know a rule for perimeter, right? It was 2 length plus 2 width. And we were given it was 60 meters. And then we're just looking at those horizontal distances. 1 plus 2w plus 1. Great, we've got the length of the big rectangle in terms of that width of the garden, which we want to eventually solve for. Then we look at the verticals. We can rewrite that vertical distance in terms of the little width. And then it's just simply a matter of solving. You have to make sure that this is length of the big, and this is width of the small here. Okay, and then you're just substituting. And yeah, so I think that the hardest bit is getting this diagram right and interpreting that information. And then once you get it in terms of one variable, you're good to go.